Hi everybody, welcome back to my channel. So today we'll be seeing problems on aromaticity that were asked in CSIR NET and NEET examinations. So the first question is the aromatic compound among the following. So they have given 4 compounds. You will have to identify which among the following is aromatic. So before we solve the problem, we know if for a compound to be aromatic, it has to be cyclic and it must be planar. There must be delocalization of pi electrons. Also it must obey Huckel's rule. That is, it must have 4n plus 2 number of pi electrons. If it doesn't obey any of the above criteria, then it is considered as a non-aromatic compound. And in case if it obeys the first 3 criteria and it has 4n number of pi electrons, then it is an anti-aromatic species. So we'll have to take each compound and check if it obeys all the 4 criteria. Now if you see the first compound, yes, it is cyclic. Now second criteria is it must be planar. Not all carbons on this benzene are planar. The top carbon is having tetrahedral geometry. So we conclude that this is a non-aromatic compound. Now moving on to the second one. It is a cyclobutadiene. So now it is cyclic. There is delocalization of pi electrons and it is planar. Now all carbon atoms are having sp2 carbon atoms. And now if you check for the Huckel's rule, it is having 4 pi electrons. That is, it is having how many number of pi electrons? 4n number of pi electrons. So it is an anti-aromatic species. Now moving on to the third molecule or compound that they have given. It is a cyclopentadiene carbocation. Now we will check one by one. So yes, it is a cyclic compound and then it is planar. All carbon atoms are having sp2 hybridized carbon in it. And then if you check for delocalization, there is no delocalization in pi electrons. There is a hindered flow of pi electrons. So we conclude that it is a non-aromatic species. Now we will go to the last compound. Yes, it is cyclic. All the carbon atoms are in plane. That is, it is having sp2 carbon atoms and there is delocalization of pi electrons. Now is it obeying Huckel's rule? Yes. The negative charge is involved in the delocalization. So it is having how many number of pi electrons? It is having 6 pi electrons. That is equal to, that is, it obeys Huckel's rule. Therefore, among the 4 compounds that are given, your option D is an aromatic compound. So we'll have to go one by one, check for each compound if it is obeying the 4 conditions for aromaticity and then proceed. Now we'll go to the second question. So all these were asked in previous year's NEET exam. So now the question 2 is, which of the following compound is not aromatic? They are asking you to identify the compound that is not aromatic. When you are reading the question, please be very careful. Are they asking you to identify the aromatic compound or the non-aromatic compound, or are they asking you to check for anti-aromaticity? So you have to be very careful when you are reading the question. Now move on to the second one. So you have to find the compound that is not aromatic. The first one they have given is a pyridine molecule. Now you have a heteroatom that is nitrogen. Nitrogen has 1 lone pair of electrons. Now we will go one by one. See if the compound is cyclic. Yes, it is cyclic. Check if all the atoms involved in the compound are planar. Yes, all carbon atoms including the nitrogen is sp2 hybridized, that is, it is planar. Now the third thing that we have to check is delocalization of electrons, pi electrons present. Yes, all your pi electrons are delocalized, are involved in delocalization. So it obeys the third condition too. Now check for Huckel's rule. Yes, it is having 6 pi electrons that are involved in delocalization, which obeys the Huckel's rule. So pyridine is an aromatic compound. Now move to the second one, cyclopentadiene anion. This we had solved in the previous case. The same one. It is cyclic. It is having a planar geometry, and then there is delocalization of pi electrons, and it obeys Huckel's rule. So it is also an aromatic compound. Now move to the third compound. It is a pyrrole. So now in pyrrole, if you see, nitrogen has one lone pair of electrons. So usually when they are giving heterocyclic compounds, they will not be mentioning the lone pair of electrons in the structure. We must be aware of it and take note of the delocalization with utmost care. Now first we will see, is it cyclic? Yes, it is cyclic. Second, check for planarity. All the atoms involved are planar, having sp2 hybridization. 3, check for delocalization. Yes, it is delocalized. Now why I told you have to take note of the lone pair of electrons with care. Now see here, nitrogen's lone pair will be involved in delocalization. Now if you see in case of pyridine, the lone pair of electrons on nitrogen need not involve in delocalization, because the one in the 6-membered ring, already it has 3 pi electrons that are involved in resonance. So it doesn't need the lone pair of nitrogen. But in case of pyrrole, it needs the lone pair, okay, on nitrogen to complete its resonance. So yes, there is complete delocalization of pi electrons in pyrrole. And then see if it is obeying Huckel's rule. Yes, there are 6 pi electrons that are involved, and it is obeying Huckel's rule. So pyrrole is also an aromatic compound. Now moving on to the last one, they have given cyclopentadiene cation. Now if you see, it is a cyclic compound having planar geometry. Okay, all the carbon atoms are sp2 hybridized. Okay, and if you check for delocalization, there is no complete delocalization of pi electrons. So it is not obeying the aromatic compound conditions. Therefore, cyclopentadiene cation is a non-aromatic compound, and therefore the answer for this question is option D. So the questions are very simple. You just have to go stepwise and don't answer the questions in a hurry. Okay, so when you solve each problem by understanding the concepts, it will be very easy for you to find the answers. And in most of the competitive exams, a minimum of 2 marks and to a maximum of 5 marks they are asking from aromaticity concepts, which makes it easier for you to score marks. Now moving on to the third question. So they have given 7 compounds and they are asking you to tell how many among them are aromatic. So they have given the options, they have given certain numbers. So you have to tell if 4 compounds of this are aromatic or 5 are aromatic. So to answer this, again you have to check the conditions of aromaticity in all the given compounds. So the first one is a naphthalene. It is cyclic. It is planar with all carbon atoms having sp2 hybridized carbon atoms, and then there is delocalization of pi electrons. There is complete delocalization, and then you check if it obeys Huckel's rule. Yes, it is having 10 pi electrons, which fits under the 4n plus 2 number of pi electrons. So what? Naphthalene is aromatic compound. Now moving to the second one, it is furan. Now the compound is cyclic. It is all the atoms involved in furan or planar having sp2 hybridization, and then check for delocalization. One lone pair on oxygen atom will be involved in delocalization. So yes, all the pi electrons are delocalized. Now check for Huckel's rule. It is involving 6 pi electrons in delocalization. So it obeys Huckel's rule, and therefore furan is an aromatic compound. Now cyclobutadiene. So if you see a series of questions, the same compounds would have repeated. So if you practice enough number of times, it will be easy for you to solve it at the site of the question. So now if you see, it is a cyclobutadiene. Now it is cyclic, it is planar, all carbon atoms are sp2 hybridized, and there is delocalization of electrons, but it doesn't obey Huckel's rule as it is having only 4 pi electrons. So it falls under 4n pi electrons, anti-aromatic compound. So cyclobutadiene is an anti-aromatic compound. So now the fourth compound that they have given is cyclopropenyl anion. It is a cyclic compound having a planar geometry. All the carbon atoms are sp2 hybridized, and there is delocalization of pi electrons. Now check for delocalization of pi electrons. The negative charge is involved in delocalization. Now if you check for the Huckel's rule, it has 4 pi electrons. So it obeys 4n rule, and therefore cyclopropenyl anion is an anti-aromatic compound. Now we will see cyclopropenyl cation. So if you see, the compound is cyclic. It is having a planar geometry with sp2 hybridized carbon atoms, and there is delocalization of pi electrons. This carbon has a vacant p orbital to which the pi electrons can be transferred. So there is delocalization of pi electrons. And is it obeying Huckel's rule? Yes, it obeys, because it has only 2 pi electrons involved. So it is an aromatic compound. Now this is cyclooctatetraene. So one by one you have to go. You mustn't jump each condition. So now it is cyclic. It is having sp2 hybridized carbon atoms. But this is not a planar structure. Cyclooctatetraene exists in tub shape. It exists in a tub shape. So it is a non-planar molecule. So since it is non-planar, it doesn't obey the conditions for aromaticity, and therefore it is a non-aromatic compound. Okay. Now the next one they have given is anthracene. So if you see, it is cyclic, planar, there is delocalization of pi electrons. Check for Huckel's rule. So how many pi electrons are there? 1, 2, 3, 4, 5, 6, 7. It is having 14 pi electrons, which again obeys 4n plus 2 rule, and therefore it is aromatic. So now count the number of aromatic compounds. 1, 2, 3 and 4. So you are having 4 aromatic compounds. So the option is answer A. Okay. So easy compounds they will give. So once you are able to visualize the molecule and check if it is planar, know how to calculate the sp2 hybridized atoms, and then know how to check, visualize the delocalization of pi electrons, it will be easier for you to find out if it is an aromatic or non-aromatic or an anti-aromatic compound. So in recent days they are giving compounds other than carbon and heteroatoms. Like I will discuss problems. So there are problems, boron compounds are there. Okay. So but the concept is same. Check if the compound is cyclic. See if it is having a planar geometry, and then check for the delocalization of pi electrons and verify Huckel's rule. If it has all the 4 conditions, it is aromatic. If it misses any one of the condition, it is non-aromatic. If it satisfies the first 3 and it has 4n number of pi electrons, then it will come under anti-aromatic compound. So now this is the fourth question. So you will have to, they have given two compounds, that is one is M and the other they have labeled as N. So you will have to tell according to Huckel's rule, is the compound aromatic, non-aromatic or anti-aromatic. They had given four options, that M is aromatic, N is non-aromatic and vice versa, and there were four options. I have not written the four options, but then we will verify if it is aromatic or non-aromatic or anti-aromatic. It was asked in NET June 2023. So it is a recent question. Okay. So now if you see, look at molecule M. Okay. It is cyclic, and see if there is delocalization of electrons. And see if it is all planar. Yes, it is planar, having all sp2 hybridization. And then check for delocalization of pi electrons. Nitrogen has lone pair of electrons and boron has an empty p orbital. So making it favorable for complete delocalization of pi electrons. So it obeys the third condition also. Now fourth one, check if it obeys Huckel's rule. Here the nitrogen's lone pair is also involved in resonance. Okay. So, if you see how many pi electrons are involved, 1, 2, 3, 4, 5. So, 10 pi electrons are involved, making it obey Huckel's rule. So, compound M is aromatic. Okay. So, see how easy it is. Only, no matter what element they give, we must be only confident or we must be only sure of the four rules. So, if we are sure, we will be able to solve the answer. Now moving on to the compound N. Okay, it is a cyclic structure having sp2 hybridization. Okay, and it is what? Planar in geometry. Now see if there is delocalization of pi electrons. Again your boron will be having vacant p orbital, making the transfer of pi electrons feasible. Okay. So there is delocalization of pi electrons. See if it obeys Huckel's rule. Yes, there are 6 pi electrons that are involved. So it obeys Huckel's rule and therefore the compound is aromatic. So based on the options, you don't solve the problem. Solve the problem and check for the options. Now you will be having 4 options. The correct one is where M is aromatic and N is aromatic is the right option. So if you are able to solve this, you will be able to get the mark. Okay. So this is the last question that we will be discussing for our video today. So this was asked in CSIR NET September 2022. So as I said, in recent years, a lot more questions are being asked from aromaticity, making it easier for you to score marks. Okay. So you have to identify, they have given 3 compounds and you will have to identify which among the following are aromatic. So it's okay, don't look at the structures and be, it is not a familiar structure, don't feel so, okay, because the concepts are the same. You have to check for the 4 conditions. So we'll go one by one. Look at the first compound. It is cyclic, it is having a planar geometry, having all sp2 hybridized atoms, and then there is delocalization of pi electrons. Is it obeying Huckel's rule? Yes, it is having 6 pi electrons. So it is obeying Huckel's rule and therefore it is aromatic. Now you look at the options. While solving, while attending competitive exams, the time factor is very, very important. So now you have found that option A is aromatic. Compound A is aromatic. Now look for the options that doesn't have A. Now your second one and your fourth option doesn't have A, so straight away eliminate it. Now we have to go check for B and C. Now if you see compound B, it is having sulfur in it. Sulfur belongs to oxygen family and it has 2 lone pairs of electrons. Remember, they will not be giving the lone pair of electrons. We will have to know it. Okay. So it is a cyclic structure having a planar geometry and there is delocalization of pi electrons. Okay. The lone pair in sp2 hybridized, the lone pair in sulfur atom is involved in delocalization. And does it obey Huckel's rule? Yes, it obeys Huckel's rule. Okay. How many pi electrons are involved? 1, 2, 3, 4 and 5. 10 pi electrons are involved. It obeys Huckel's rule and therefore it is aromatic. Okay, so your A and B are aromatic. So now if you see, look at option 1 and 3, only your option 3 has A and B. So you can straight away select the answer. Option 1 is wrong. Now anyway, we will be discussing compound 3. Compound 3, if you see, it is a cyclic structure, but it is not having a planar geometry. Why? This carbon atom is having tetrahedral geometry. Okay, so it is not obeying Huckel's rule, it is not obeying the aromaticity conditions and therefore it is a non-aromatic compound. So hope you would have got some idea on how to approach problems on aromaticity. So we have discussed 5 problems. There are a lot of problems, and for this video we have discussed 5 problems that were asked in your competitive exams, that is your NEET and NET exam. So whatever be the exam that you are preparing for, or whatever be the whatever bias you may have on chemistry, chemistry is a very easy subject when approached and learnt in a systematic manner. So I wish you all a happy learning. Thank you.